We start at the beginning, more or less, with the natural numbers. I'll say a little bit more about the rock bottom beginning later on. So the natural numbers, also called the positive integers, 1, 2, 3, etc., are used for counting. For example, we might have 1 apple, 2 oranges, 3 bananas, etc. Or we might be 1 metre, 2 metres, 3 metres above sea level. Or we might have $1, $2, $3 or more in our pocket. It's convenient to have a number 0, which in the previous examples would correspond to having no pieces of fruit, being at sea level, or having no dollars in our pocket, in our bank account. It's also convenient to have negative integers, -1, -2, -3, and so on. So in the previous examples, -2 might correspond to owing someone 2 pieces of fruit, being 2 metres below sea level, or owing our friend $2. The positive integers, 0, and the negative integers are all called integers, and it's convenient to arrange them in an order as follows: ... -3, -2, -1, 0, 1, 2, 3, and so on. More generally, we have the real numbers. I'll say more about these in subsequent modules, but in this particular module, we'll only be dealing with the integers. We also assume the usual properties of addition, multiplication, and order for the integers. For example, we have x plus y equals y plus x for any 2 integers x and y. We have x times y plus z is equal to x times y plus x times z. We have 0 with the special property that x plus 0 for any x gives you me x, and 1 with the special property that x times 1 is equal to x for any x. Minus x is the number which, when added to x, gives me 0. This is true for any integer x, any number. In our case, any integer. We have the properties of order. For example, if x is less than y, then x plus z is less than y plus z for any x, y, and z. We also have the property of induction, which we won't particularly need in this online module. Now I'm going to make a couple of what I like to call starred remarks. Every so often I'll make some remarks to put ideas into a broader context. It doesn't matter if you don't follow the remarks, just relax, sit back and get the general idea of what we're talking about. And later on in this course, maybe in subsequent courses, the ideas will become clearer. But starred remarks are not essential for your understanding of the material. So the starred remark now is that a small group of similar properties to those we just saw for addition, multiplication, and the less than relation, plus induction, a small number of such properties, are sufficient to derive, using the rules of logic, all the standard properties of the integers. We can even go one step further and we can formalize the logic itself, such as if a statement P is true, and if the statement P implies Q is true, then the statement Q is true. We can formalize all the rules of logic which are needed. Formalizing this logic is critical for analyzing the foundations of mathematics, and also in computer science for understanding computer algorithms, for developing artificial intelligence, for example. The integers, together with the real numbers, as I mentioned before, can be arranged on the number line. So the real numbers are the numbers which fall between the integers, for example 3.1415 and so on, which is the first 4 digits of the number pi. Real numbers are critical throughout mathematics, but we don't really need them actually, apart from integers, in this particular module. Finally, another starred comment. The real numbers can also be extended to the complex numbers. The usual properties of addition and multiplication still hold, but the order relation less than does not hold. In addition, there is then a number I whose square is equal to -1. And it turns out the complex numbers can be represented as points in the plane, just as real numbers can be represented as all the points on the line. Complex numbers are essential in analysing any sort of periodic behaviour. They're essential in quantum mechanics, in quantum computers, and in a host of other areas. End of starred comment.